as well. So for recording purposes, today's topic is probability, and we have a little game to play here. And this is the game here, right? What's going to happen? There's an evil doctor who has decided to reduce global warming, and he's going to do what? Freeze everyone in the Caribbean. At the end of class, or well, hopefully at the end of our probability, only one animal is going to be alive. Only one animal is not going to be frozen by Dr. Evil's ice ray. You all want to take a guess of who it is, and whoever you choose, you have to stick with it till the end of probability, right? So only one animal is going to survive. Who do you think it is? And let's see if you can win the game today, right? Let me know on the check slide here. So as I mentioned, we're going to start off with this thing called probability. Now, probability is just the chance of something happening. Do not take down all the formulas on the screen. It makes no sense taking down all the formulas if you don't know how to use the formulas. Now, we're going to start off with the most basic type of probability question, obviously, first. So you're probably asking, well, can Sir give me a very simple definition or a very simple explanation of what probability is? Well, probability is the chance of something happening. It puts a mathematical value on the possibility that something will happen. For example, tomorrow, what are the chances? Well, another word for probability is chances. Well, what is the probability or chances there will be sunshine tomorrow? Answer that question on the chat. Let's see how you all would answer that. What is the probability or chances that there will be total sunshine tomorrow? I mean, remember, nobody knows for sure, right? Because we have, even if you read the weather report, that doesn't guarantee that the weather will actually happen the following day, right? So some people are saying, well, maybe, and some people are saying they're putting a percentage on it. Like tomorrow, the chances of sunshine is 50%. So it's 50-50. And some people are using decimals. Whenever you are measuring probability, right? You're trying to calculate a value for probability. And here's the good thing. The answer for any probability does always be between 0 to 1. So if you ever do like a probability question and your answer is smaller than 0 or larger than the number 1, you did something wrong. All probability falls between 0 and 1. The closer the answer is to 0, in other words, if something has a probability of 0, that means it will never, ever, ever, ever happen for all practical purposes. So if you calculate the probability of something and you get 0, it means it will never, ever happen. And if you calculate the probability of something and you get exactly 1, that means it will happen. So I'll give you an example of something that has a probability of 0, right? I mean, for all practical purposes, when you wake up in the morning, the sun will not be there. Now, the chance, I mean, for all practical purposes, right? We know that's never going to happen, well, at least in our lifetime. So the probability of the sun disappearing tomorrow is, for all practical purposes, 0, right? So, and what has a probability of 1? Well, what will happen for sure? Well, the chances that we wake up in the morning and the sun will rise has a probability of 1. The sun will rise in the morning. Now, the probability of being alive tomorrow technically is not 1, right? Unfortunately. Anything else in between has a chance of happening. Like, for example, if I calculate the probability of something and I get 0.35, That's closer to 0, right, than 1. So if we calculate the probability of something and we get 0.35, that means we are not too sure if it's going to happen. It's still up in the air, but it's actually closer to not happening because 0.35 is closer to 0 than to 1. But anyway, the moral of the story is this. When we do our calculations, if our answer doesn't fall between 0 and 1, we did something wrong. All right, so let's do me a small favor. Just take down what I wrote here, 0 to 1, and take down what I wrote in pink. I know it's a very simple note, but still take it down. Right, just take a 20 seconds and take that down. Okay, so here's the scenario. You all see the animals and the characters at the top of the screen, and they're on a plank supported by a rope. We're going to pretend that we're going to shake that plank. We're going to shake the rope, and animals are going to fall into the cactus patch. All right? Obviously, a very traumatic experience. Now, we have to put some rules in place for this quote-unquote scenario. Here's the rules. When we shake the rope, only one animal can fall. I mean, only one character can fall. Two characters cannot fall. 3 characters cannot fall. When we shake, only one will fall. So keep that. Well, actually, let me write that because a few people might forget, right? Only one can fall. So no one will forget. Okay. So we want to calculate the probability that when we shake, a zombie will fall. And this is the simplest types of probability question. The formulas you use for a simple scenario like this, I'm going to highlight it in yellow, is this. What I'm circling in yellow, the 3 of them is actually the same exact formula, except they're written slightly different. To calculate the probability of a very simple situation like this, all you have to do is create a fraction. Let me show you. It's better to actually show you rather than explain the formula. To calculate that the probability of a zombie falling, you put P open brackets Z. I write my Z with a little slash there, so you don't confuse it with the number 2. This P stands for probability, and it means the probability of a zombie falling, PZ, is equal to, and you create a fraction. Now, a fraction obviously has a numerator and a denominator. The numerator is the amount you care about, and the underneath is the total amount. Let me explain what that means. In this question, how many zombies do you have? Very simple question. How many zombies do you have? 2. So the numerator is the amount you care about. Right now, the question was, what's the probability of a zombie falling? Well, how much zombies do we have? We have 2 zombies, and the denominator is the total amount of characters. What's the total amount of characters? 1, 2, 3, 4, 5, 6, 7, 8, and 9. The answer is 2 9s. That's the end of the question. So at the end of the day, right, to calculate simple probability is what you care about that goes on top, the amount you care about. In this case, we care about the amount of zombies divided by the total amount of everything. And this is what this formula is saying at the end of the day. I know it looks complex, but what I circled in yellow is what the formula is trying to say. All right, so let's repeat this experiment. What is the probability that when you shake, a seal will fall? What's the probability of a seal falling? It's the same answer, right? And the only reason it's the same answer, and this is how you want to write it for your examiner, you try to choose letters that kind of depict what's going on in the scenario. So if the examiner is talking about seals, I'm going to use the letter S. That's the most logical letter to use, right? So the probability of a seal falling, how much seals do we have? We have 2 seals, right? And then we have 9 characters in all. And obviously, if I ask you the question, what's the probability of a dog falling, right? What's the probability of a dog falling? I will use the letter D. How much dogs it have? 1, 2, 3, 4, 5. And it have 9 characters in all. Now, somebody said 4. It have 5 dogs, counted properly. It have 5 dogs in all. Now, obviously, for these questions, right? You can't expect too much marks, right? But they do come in the exam and they're just worth 1 measly mark. Quick question. When I shake the rope, what's the probability of a dog and a seal falling at the same time? I'll repeat the question. When you shake the rope, what's the probability of a dog and a seal falling at the same time? Let me see if I can trick you all. And the examiner will try to trick you all there. Right? Now, I'm going to do the wrong thing first. Right? I'm going to do the wrong thing first because some people did put the wrong answer. So, the probability of a dog and a seal falling. This intersect means and, but we'll discuss that later. But the probability of a dog and a seal falling. All right. So some people said it had how much dogs and seals together? It have 5 dogs and 2 seals, so like 7 in all. And then we have 9 characters in all. This is wrong because the examiner told us at the question how much animals can fall at a time? Only one. Only one animal can fall. So according to the rules of the scenario, the examiner gave us rules. The answer is 0. That could never happen. For those who got it wrong, you understand how the examiner tried to trick you? Because the examiner at the beginning of the question stated conditions for the question. He or she said, no and only one animal can fall. That's the rules. So if I come and ask you if 2 animals could fall, that can never happen in this particular situation. You gotta be careful with that in the exam. I've seen plenty Form 5s fall for those simple tricks. All right. So everyone okay so far? All you need to do right now is just take down these 3 formulas. And if you, hey, what, you don't need to take down anything here for the time being. It's too simple to take down, and I'm going to be repeating it like 100 times for class today. All right, so we're moving on, okay? Let's move on to the next slide here. Let's try some easy probability questions using 1 dice. Now, there are 2 types of questions, 2 major types of questions involving dice. Is either we use 1 dice or we use how much dice? Well, 2 dice. We're starting off with a very simple one. If I were to throw a dice, what's the probability that I will get the number 3? So this is how we're going to write the question. If I throw a dice, just 1 single dice, what's the probability of it landing on the number 3? Send your answers on the chat. You don't have to get it correct. You just have to try. Remember, the top value, the numerator, is what you care about, and the underneath is the total. Now, don't send your answer as a percentage. Send your answer as a fraction or a decimal. In this case, a fraction would be better. Right? Right. So here's a very popular mistake. Some people are saying the answer is 3, 6. Now, I want to explain why this is wrong, and it's a very common mistake. It always happens. A lot of people see the number 3 here. So they will say, well, the number 3 is what I care about. And a dice has how much sides? 6 sides. So naturally, you say 3 over 6, but it doesn't work like that. The top number is what you care about. How many number trees is the amount of it, not the actual value, is the amount of it. How many number trees does a dice have? A dice only has one number tree. And how much sides does it have in total? 6. So the answer is 1/6. You see, it's not the value number tree. It's the amount of number trees. For those who got it wrong, you think you understand it? The top number is the amount that you're considering at the moment, and the underneath is the total amount of possible things that could happen. Great. So let's try some trickier questions, all right? What's the probability that when you throw a dice, you will get an even number? Send your answer as a fraction. When you throw the dice, what's the probability it will be an even number? Right? And if you get a fraction, you have to reduce it in the exam. Otherwise, you lose marks. Right, getting plenty correct answers. Great. So a dice has 3 even numbers, right? 2, 4, and 6. Those are the even numbers. So it has 3 even numbers. And we all know a dice has 6 possible sides. So when you reduce it, you get what? A half or 0.5. It doesn't matter if you put it as a fraction or a decimal. Now I'm going to put two questions, and it's going to look almost the same. But if you look carefully, you will see a difference. When I throw the dice, what's the probability that the number will be more than 3? You see how I write it there, right? More than 3 versus the next question. I'll use a different color. When I throw the dice, what's the probability that the value will be more than or equal to 3? Send the answer for both of them. Or would we get the same answer for both of them? Well, what do you guys think? These are very popular 1-mark questions in the AdMath section last year. The main idea here is to show you the difference between these two questions. In the first questions, I'm asking, what's the probability when you throw a dice, you get more than 3? Well, inequalities, more than 3, does that include the number 3? If I say I want more than $3, is it okay to give me exactly $3? No. If I tell you I want more than $3, then I want more than 3. I don't want exactly 3. So more than 3 could be 4, 5, or 6. It have 3 possible outcomes that are more than 3. So the answer will be 3/6 because you have 3 values that are more than 6. However, if the examiner were to ask you, what's the probability of throwing something more than or equal to 3? Well, in a case like that, more than or equal to 3 includes the 3. So you have 4 possible outcomes. 1, 2, 3, 4. So you will get 4/6 rather than 3/6. And of course, in the exam, I have to reduce both answers. This one would be a half, and the other one would obviously be what? 2/3. Take down all 4 examples here. You see the one in red and blue? You won't believe how popular those 2 questions are in the exam. And it's just a subtle difference between understanding indices, the more than or equal to. Let me know when you guys are finished. All right, so let's see what's next on the list. Oh, we reach a little cut screen here. All right, so who do you think will be the first to get frozen by Dr. Evil? Who will be the first animal to be frozen to help to reduce global warming? Any volunteers of names? Somebody said Jerry. Who is Jerry here? Jerry is a jellyfish. All right, so let's see who it will be. Let's see. We're sorry to announce the frozenification of Otis the Omar the octopus. Anybody out of the game? Because Omar is gone. He has turned into an ice cube. Anybody out of the game? I'm still in the game because I believe I chose. Who did I choose? I can't remember who I chose. Nobody out of the game? All right, let's move on. Let's move on. I chose Sam. All right. All right, let's move on. What about the probability of 2 dice? What popular game you all know uses 2 dice? You all must know. It starts with the letter M. What popular board game? Monopoly. That's probably the most popular game that when you use what? 2 dice. When you throw 1 dice, there are 6 possible things that can happen. We all know this when you throw a dice. So a lot of people think that when you throw 2 dice, how much possible outcomes can you have? Is it 12? It's not 12. Common sense? Well, this is where common sense kind of fails, right? If 1 dice is 6 outcomes, 2 dice is not 12. 2 dice has 36 possible outcomes. If you ever paid attention when you was playing Monopoly, when you throw 2 dice, you realize it have 36 different combinations. I know it's hard to visualize, but if we use the power of graphs, we can actually see this. And I'm going to prove it to you guys, right? Let me just, you see, whenever you're throwing 2 things at the same time, in probability, like it could be 2 dice, it could be 2 coins, it could be 1 coin and 1 dice. That's 2 items. It's very, very useful to draw it out on a graph. Let me explain why. How? We're going to have a y-axis and an x-axis. One axis is going to represent one of the dice, and the y-axis is going to represent the other dice. On the first dice, and then have 6 possible things. You could throw a 1, a 2, a 3, a 4, a 5, or a 6. On the other dice, the y-axis, you could also throw a 1, a 2, a 3, a 4, a 5, and a 6. So when you throw the 2 dice together, isn't it possible to throw a 1 and a 1? Well, what do you call it when you throw a 1 and a 1? Well, what's the name for that? When you throw 2 ones playing Monopoly. Well, what you call that? It starts with the letter snake eyes. Correct. You call that snake eyes, right? Or, and you could choose a 1 dice could fall on a 1 and the next one could fall on a 2. You all see the pattern here. And 1 dice could fall on 1 and the next one could fall on 3. So in other words, every intersection here is a possible outcome. For example, this one here means you could throw a 3 on 1 dice and a 2 on another dice to give you 5. Like this one here. My total, if I throw 4 on 1 dice and throw a 4 on the next dice, the total would be 8, right? So, and if you put all the dots here, you will get how much dots? 36 dots. The easy way to do that is just say 6 by 6, which is 36. So I want everyone to draw this diagram for me. I'm going to give you 2 minutes. Draw this diagram, and we're going to work out some questions on it. Let me know when you're finished. Draw a neatish diagram, and don't draw it too small. Draw it so it like fits half of your page. So we're going to pretend we are playing Monopoly. Anybody has a favorite color in Monopoly? Like, for me, I always like the oranges. Like that's what Tennessee Avenue and whatnot, right? Anybody have a favorite? I don't actually like Park Place and Boardwalk. Right? The light blue, yes. I love the light blues. All right. So, first question. And I'll work out the first one with you. What's the probability that when you throw the dice, it will, let me see. What's the probability that you will get exactly 5 in total? So let's say you needed 5 to land on chance. So you throw the 2 dice. What's the probability that you will get exactly 5 in total? Well, we can work out the underneath part first. Remember, The underneath part is how much total outcomes are possible. And we now stated that it have 36 possible things that can happen. So the underneath part here is okay. Now, to get a 5, there are many ways we could get a 5, right? Right, and the class, I just want to point out the classes will be fully recorded and uploaded tomorrow. So there are many ways to get exactly 5, and one dice could fall on 1 and the other dice could fall on 4. Isn't that one way of getting a 5? One dice on 1 and the other one on 4. Or one dice could fall on 2 and the other one could fall on what? 3. Or the first dice could fall on 3, but the second one could fall what? On 2. Or the first dice could fall on 4 and the second dice could be on 1. So how much different ways it have to get a number 5? A lot of people rushed and said the top value had to be 1. But upon analysis, and the numerator are all the possible ways, is the amount of possible ways it could happen. So the top value is actually what? 4. Right? Zuriel, I'm not too sure why you said 15 over 36. It have 4 possible ways to get the number 5. Zuriel, let me know if you understand the mistake, right? And of course, we have to reduce this, right? If we reduce this, help me reduce this. Oh God, I can't even reduce this in my head now. 4 over 36, 9, oh, 1/9, right? So the actual answer you want to send for the examiner is 1/9. Right? Right. So let's try to answer, and so everyone okay with that, right? You understand how I got 4 and 36, right? I know the class kind of tired, they had a whole day at school and whatnot, but still try to participate, right? Put in, make yourself known in class. Okay, so quick question, another question. What's the probability? Let me erase this here. That's not. Sorry, one second, guys. Sorry, one night. Next question. What's the probability that when you throw the dice, you will get exactly 10? Calculate that one for me. So let's say you need 10 to land on Charles' place. What's the probability of getting that 10? Pretend you're getting $1 million for getting it correct. So how many different ways can we get a 10? Well, the first dice, I call it the blue dice. The blue dice could fall on 4, but the next one would have to fall on what? 6. So 6 plus 4 is 10. Or one dice could fall on 5, and the other one could also fall on 5. Or the blue dice could fall on 6, and the second one could fall on 4. I think that is it only have 3 ways of getting what? 10. So it's 3 ways to get 10, and a dice has 36 possible, well, 2 dice, sorry. So the answer is 1/12 if it is what? Reduced. Right. Quick question, another question. I want to put an inequality question here because, it's very popular in the exam. What's the probability, right, that when you throw the 2 dice, it will be more than 10? More than 10, not more than or equal to 10. More than 10. More than 10 means 11 or 12. You cannot exceed 12 on 2 dice, right? Because we know in Monopoly, that's the maximum, right? Annabelle, you sure? More than 12. I mean, more than 10. Remember, more than 10 means you're either getting 11 or 12. So to get a 11, the first dice has to be on 5 and the second one has to be on 6. Or the first dice has to be on 6 and the other one has to be on 5. These two ways will give you 11. But isn't 12 also more than 10? If one dice falls on 6 and the other one falls on 6, then we'll get 12. So there are 3 ways to get more than 10. A lot of people forgot to count the 12, the 6 and 6. So it just so happens we get the same answer as above. That's coincidence. So 3 over 36, when you reduce it, you get what? 1/12. Take down all 3 answers, right? And we'll move on to the next slide. All right. So another popular question is, instead of having 2 dice, you have 1 coin and 1 dice. So like, for example, if you throw the 2 of them at the same time, the coin could land on heads and the dice could land on 3. How many possible outcomes it have in a scenario like this? If you throw 1 dice and 1 coin at the same time, how many different possible things can happen? Malachi, check it back, check it back. No, Malachi, correct. That's yeah, Malachi, correct. Yeah. Right. Remember, if you draw out the scenario, it could be real easy to figure out, right? Because once again, it's 2 items, but instead of it being 2 dice, it's 1 coin and 1 dice. So you draw like an X and a Y axis. You call one axis will represent the dice and the other one will represent the coin. It doesn't matter which way. But the X axis for me, I'm gonna make it the dice. So if I throw the dice, it have 6 possible things can happen. You can throw a 1, 2, 3, 4, 5, or 6. And when you throw the coin, you're either gonna get what? A heads or a tails. How many possible different things can happen here? You could throw a 1 and a heads, a 1 and a tails. You'll get the idea here. Every intersection is going to be a possible outcome. So how much dots we gonna get there? 12 dots, right, Durga? You understand the mistake? And it's real easy. Remember, it have 2 possible outcomes on the Y and 6 possible outcomes on the X. So 6 by 2 is 12. That's how you just do it. 6 by 2 is 12. All right. So let me give you a question. What's the probability of getting an even number and, this is how they just write and, right? And a tails. What's the probability of getting that at the same time? Like you throw it and you end up with an even number on the dice and a tails on the coin. So what are the conditions for this simple scenario? I get green here. So we need an even number and tails at the same time, right? We need both of them at the same time. So that is what and means. And means it's happening at the same time. So there are 3 even numbers, 2, 4, and 6. So to meet the conditions, you could throw a 2 and a tails, or a 4 and a tails, or a 6 and a tails. It only have 3 possible ways to satisfy those conditions. So it's 3 on top, it have 3 ways. And how much ways it have in all? We just said that 12 ways in all. So 3 divided by 12 is a quarter. For those who got it wrong, you think you understand it now? It's an even number and a tails at the same time. Right? Right, so that one, this one not too hard. Let me see if I can just get one more. Let's make up one more on the spot here. What's the probability of getting a value more than 5 and a heads. So when you throw the both of them, you must end up with a number more than 5 and a heads at the same time. Answer. Now remember I said more than 5, not more than or equal to 5. More than 5 means, well, the highest number you can get with one dice is 6. So a 6, the only way to meet that conditions is a 6 and a heads. There's only one way. So the answer is 1/12, not 1/6. If I said more than or equal to 5, then you could have included 5 and the heads, but it was more than 5. For those who got 1/6, 1/6. You understand it now, right? The answer would have been 1/12. I think the inequality is giving a few people problems. More than 5 means, well, just that. More than 5, you cannot include 5. All right, so take a 10 seconds. Just take down my answer for the red question there. Let's move on. All right, let's see who's next to go. Omar the octopus is gone. Let's see who's the next victim of Dr. Evilo. We're sorry to announce the frozenification of Fonzo the fish and from Jamaica. Anybody out of the game? Did anybody choose Fonzo or Omar? If you do, right, you're out. Right? And just to answer a question, the easiest way to do the question is using the graph, like when you have two items. The only other way to do that is to imagine the graph. So draw out the graph to always draw out the graph to do those questions. Always. Don't take no chances. Somebody is out. Anjali, you are out of the game. All right, let's go. All right. So we're going to learn to calculate opposites, right? This is going to be super easy. I trust everyone here can subtract. All right. Everyone here should be able to subtract. So if I come and tell you the probability that it will rain tomorrow is 0.3. So I come and tell you that, and I have a little cloud there with rain and whatnot, and I use the letter R for rain. What is the probability that it will not rain? To say not rain, like if you want the opposite, if the letter R stands for rain, not rain, you put a little dash on top. This actually means not rain. That's a symbol for it. So anytime you want to not something or try to say the opposite of something, you just put a little dash on top of it. So remember probability, the maximum probability you can have is 1. Anytime you want to find the opposite of something, if they give you the probability of it happening to find the opposite, you just simply minus it from 1. So the probability that it will not rain is 1 minus 0.3, which is how much? 0.7. As simple as that. So the probability it will not rain, you just take the 0.3 and minus it from 1. Why from 1? Because 1 is the total probability of anything. When you have any scenario and you add up all the possibilities, the total is supposed to be 1. So let's try another one. If I come and tell you, God forbid, that the probability that you die tomorrow is 0.8. So that's the probability of you dying tomorrow. What's the probability that you will not die? You see how I did it? I took the letter D and I put a little dash on top. What's the probability of not dying? You just take that 0.08 and minus it from 1. As simple as that, right? No, it's 0.08, Luke. Yeah, you put try back now, Luke. It's 0.08. You put 0.8 by mistake on your calculator. Right, it's 0.92. Simple, right? So last question, and it's obviously going to be super easy, right? Right. Some textbooks, as far as I know, right, instead of a dash, right, I noticed some people will put, like, if for the R, they will put R and put a little dash like this. That can also work. I've seen people do this, but as far as I know, the one with the dash is the more used one. I would prefer if you put the dash rather than the little comma. Wait, I forget what you call that. The little semicolon. I forget what you call that in here. I prefer the dash. So what's the probability? When you throw a dice, we know the probability of throwing a 5 is 1/6. We know that calculation. So what's the probability that you will not get a 5? You see how I did it? A 5 with a dash. That means the probability of not getting a 5. Simple stuff, right? You do that in your head. Right, and everyone's getting the answer. It's just 1 minus 1/6. Primary school question, you'll get what? 5, 6. Take down everything on the screen there, right? Take down the 3 examples and let me know when you are finished. Right? All right, fair enough. I didn't expect a cutscene so far. So fast, sorry. But let's see who's next to be frozen. Next on the list is Shaka the Shark. Anybody out of the game? Shaka is from, I think that's Guyana's flag. So he's from Guyana and he's out. Stephanie, you are out. Anybody else? Shiva, you are out. Chantel, you are alive. Javon, you are still alive. All right, let's go. All right. So we're going to do something called independent events, right? And it's going to be this formula over here. I didn't write it in. Everyone take down this formula. This is for independent events. And that's PA multiplied by PB, right? There's a multiply in between the PA and the PB. Just take down that formula. Don't worry, I'm gonna explain, right? It's how easy this is to use. Independent events are 2 things or 3 things or even a million things, but we'll just start with 2. Independent things, events, are 2 things that are not related to each other, meaning that one doesn't really affect the other. But for example, if you fall down tomorrow, does that have any effect on if it will rain? Are those 2 connected in realistically in any way? You falling down and rain happening. Those 2 are not connected to each other. One does not affect the other. Independent. That is what, at the end of the day, independent means. And I have a very realistic example here. Raining and an earthquake. Does one affect the other? Does raining affect earthquakes? Or does earthquakes affect rain? No. But isn't it possible for 2 of them to happen at the same time? It could be raining coincidentally, and it could have an earthquake coincidentally. So anytime you have 2 things that are independent and you want to find out what's the probability of both of them happening, you just multiply both of them. Real simple. So let's read through this question. The probability of more than one events that don't depend on each other are called independent, and the word "and" usually means multiply. So if I ask you what's the look at question 1. What is the probability that it will rain on Tuesday, and I use the word and have an earthquake? Well, the probability that it will rain a certain day, like any day of the week, is 0.4, and the probability of there being an earthquake is 0.03. So what's the probability? I write it just like how I would write it in the exam. What is the probability that it will rain on Tuesday, and this here is the symbol for and, for independent events, and it will have an earthquake? Now, if you want to be real specific, right? I mean, you can come up with your own symbols. Remember, it has 7 days of the week. How the examiner will know that we mean that it will rain on Tuesday? You can probably put a small t at the bottom here to say, and the examiner will pick up, hey, that t means Tuesday. So what is the probability that it will rain on Tuesday and have an earthquake? Well, the probability to do this, we take the probability that it will rain on Tuesday and multiply it. We're using this formula and multiply it by the probability it will have an earthquake. Anybody want to finish that question for me? What's the probability that it will rain on Tuesday and have an earthquake? The two things are happening at the same time and they're not related to each other. Right. All you're basically going to be doing, I'll probably write the values on it. The probability that it rains on any day is 0.4, and the probability that it has an earthquake is 0.03, not 0.3, 0.03. You just take 0.4 and multiply by 0.03, and you get 0.012. It's literally that simple. But it's a kind of figure out in the exam if the two things are independent or not. So you have to use the imagination a little bit and ask yourself, does rain affect earthquake? And the answer will obviously be no. And sometimes the examiners be real nice. He just tell you at the beginning of the question, the two things that you're considering are independent. But sometimes he don't be so nice. All right. Anybody want to try the second one? Yeah, just try it. You don't have to get it correct. Try the second one. What is the probability it will not rain on Friday and not have an earthquake on Wednesday? I'm using the word not. This has something to do with opposites. This question. Now remember, they're asking what's the probability it will not rain on Friday and then not have an earthquake. Now we go up here. They told us that the probability that it will rain on any day is 0.4. So what is the probability it will not rain? And we just have to take the 0.4 and minus it from 1. Remember, I showed you that from the previous slide. When you want to find the opposite of a scenario, you just minus it from 1. So if I take 1 and minus 0.4, I will get 0.6. What's the probability that there will not be an earthquake? You take 0.03 and you minus it from 1. So you get 0.97. How much people did that first? Like you calculated the opposite scenarios of each scenario. Great. So let's write it for the examiner. What's the probability that it will not rain, and I put a little F here, so he will pick up, hey, this means it will not rain on Friday, and that's the symbol for and, intersect like in Venn diagrams, and not have an earthquake. So put a little thing there, right? Or if you want to be real specific, he said not have an earthquake on Wednesday. So you could probably put a small W if you want, right? So it's two independent events. When it have two independent events, we just take each one and multiply it. If it had 3 independent events, we multiply all 3. If it had 4 independent events, we multiply it by 4. But today is just 2. So the probability of it not raining, you have to put it like this, right? So we're going to take the probability of it not raining on Friday and multiply it by the probability that it will not have an earthquake on Wednesday. You have to put this work in for the examiner. You have to. So the first one is 0.6. That's this guy here. And then we multiply by not have an earthquake. 0.97. Let me get my calculator there. 0.6 multiplied by 0.97. I'm getting 0.582. For those who got it wrong, let me know that you understand your mistake. That, well, obviously, I think it'll be obvious, but I just want to know if you saw your mistake at least. Y'all want to try the third one? Try the third one, no? And send the answer on the chat. It doesn't matter if you get it wrong. Just try. Just try. Make it. So this one is 3 days in a row, right? Any 3 days, right? So the probability that it will not have an earthquake on any day is 0.97. Now we're going on the assumption one earthquake doesn't affect the other earthquake. I guess that's a logical assumption. So all 3 earthquakes are independent. So this is how you write it. What's the probability that there is not an earthquake on one day and then another no earthquake on the next day and then another non-earthquake? So this is how I would write it for the examiner. And in any 3 days in a row. So no earthquake and another earthquake and another earthquake. So you take the probability of no earthquakes and multiply 3 times. Everybody okay so far? Just like how when you had 2 things inside here, you wrote back the 2 things individually and multiplied them. Well, it just so happens that it gets repeated 2 more times to make it 3 times. So no earthquake multiplied by no earthquake multiplied by no earthquake. Say multiplying 0.97 by another 0.97 by another 0.97. Yep. You get crazy questions like this in the exam, right? I know different people are going to round off differently, but it's usually safe to go to 2 or 3 decimal places. Usually in just a 0.912673. I'm a fan of going to 3 decimal places and add maths. For normal maths, most of the time the examiner will be okay with 2. But for add maths, try to go to 3 now. You got to be a little more accurate with add maths, right? But if you're rounded off to 2 decimal places, still take it as correct. It is your first class. Take down the answer. No, I want you to take down everything here. I want you to write down the questions, take down the answers. Write down the questions, take down the answers. How much minutes you think you guys need for this? About 5 minutes? That should be enough. This one really important. I'm giving you 5 minutes for this, right? To take down everything here. Oh, 1 person finished already. Remember, you can take a screenshot if you're far from finishing. Plus, the class is being fully recorded. Let's go. Oh, we deserve a small little cutscene here. So far, Shaka the shark is gone. Omar the octopus is gone. And Bonzo the fish. Next on oh, Jerry the jellyfish is gone. Anybody out of the game? Bye-bye, Jerry. Anybody out? Anybody out? I know a few people chose Jerry. I remember plenty people chose Jerry. Zuriel, you are out. Chantal, you're alive. Micah, not too sure. You're out. Anybody else? With a class of 50 people, I swear it's the same 10 people keep talking on the chat. Annabelle, still alive. All right, let's go. All right. So we're going to look at something. Remember, all the time, we've been saying and, like this and this. Now we're going to move to or when they use the word or. Now, in Venn diagrams, right? I don't know if you all remember, it's from Form 2, Form 3. In Venn diagrams, like if you have A and B. This is A intersect B. When you see intersect, that's the word and. But that another way of saying intersect is and. But then it have or. A or B. This union, another word for union is or. So you could say A union B or A or B. Now, when it comes to or questions, we're not dealing with and questions at the moment. It's or questions. There are two possible scenarios. There's one called mutually exclusive, and then it have the opposite, not non-mutually exclusive. Mutually exclusive, you notice if you use Venn diagrams, the two circles are separate from each other. Mutually exclusive means that the two things you're talking about could never happen at the same time for all practical purposes. So can you all think of two things that can never, ever, 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 ever happen at the same time? Excluding magic. We're going to take magic out of it and supernatural things out of it. Can you name two things that can never happen at the same time? I'll start you off with one. You cannot be dead and alive at the same time. It's either you're dead or you're alive. No in between, right? No, the sun and moon could rise at the same time. That is possible. Any moon is be out during the day too. The sun and the moon could rise at the same time. Somebody say a cricket match and having rain at the same time. Or somebody had a good one. Inhaling and exhaling. You cannot be breathing in and breathing out at the same time, right? So those two things are cool, right? So mutually exclusive, right, are two things that cannot happen at the same time. And the formula you use for that is this, is the one on top. For mutually exclusive events, which are or events, to find out the probability of it happening, just add the two probabilities, not multiplier. Remember, the last questions we did was and questions. In and questions, we multiply. In or questions, if they are mutually exclusive, we just simply add them. So let's try one now. And you'll notice all the both questions I have here are mutually exclusive. And I'll prove it. We'll talk it through to prove it. Number one, what is the probability of rolling a 4 or a 3 on a dice? Now, you have to use some interpretation skills here. Make some assumptions, sorry. We're going to assume that we throw in one dice and we only have one chance. So we're not throwing the dice 2 times, 3 times. We're just throwing it once. Is it possible to get a 4 and a 3 at the same time on a dice? If you have one chance of throwing it? No. It's either you get a 4 or a 3. You cannot get a 4 and a 3 at the same time. Hence, those two things are mutually exclusive. So this is how you're going to write it for the examiner. The probability of a 4 or, remember the U is the or 3. According to the formula, you take the probability of a 4 and add it to the probability of getting a 3. What's the probability of getting a 4 on a dice? What's the probability of getting a 4 on a dice? Everyone should get this correct. We did this question not too long ago. What's the probability of getting a 4 on a normal dice? 1/6. Correct. Remember, a dice only has one number 4, and how much things it has in all? 6. And what's the probability of getting a 3? There's only one 3 on a dice and 6 possible things. 1/6 plus 1/6 is 2/6, better known as 1/3. 1/6 plus 1/6 is 2/6. When you reduce it, you get 1/3. But this is an or question, right? And when they are mutually exclusive, you just find each individual probability and add them. Literally that simple. You think you all could try the second question for me? What's the probability of rolling a 2 or an odd number on a dice? Those are mutually exclusive. Because when you throw a dice one time, you can only get one value. And a number cannot be even and odd at the same time. That's mutually exclusive. It cannot happen at the same time. Send the answer for question 2. Let's see what you guys get. Right, so we already established that these two things cannot happen at the same time. So how would I write this? The probability of getting a 2 or an odd number. So I'll put O for odd, right? Or you can write out odd if you want, so the examiner doesn't mistake it for 0. You just come up with your own ways of kind of writing it that will be easy to follow. So what's the to find out this, we have to take the probability of getting a 2 and add it to the probability of it being what? Odd. The probability of throwing a 2 is 1/6 because our dice only has one number 2 and it has 6 outcomes, plus the probability of it being odd. How many odd numbers does a dice have? 3, right? The odd numbers are 1, 3, and 5. So it have 3 odd numbers, and the total possible outcomes is 6. So 1/6 plus 3/6 is 4/6. And of course, when you simplify that, I'll put the answer down here, you will get 2/3. For those who got it wrong, you think you understand it now? It's just about finding each individual part and adding it. Right.